This is the first of 4 videos on sketching of parabolas and figuring out their x-intercepts, or their roots. So we talked about in class already, it was a 4-step procedure for sketching parabolas. And I'm going to remind you here, if you have a parabola, this is y is a function of x, this is a parabola, and you want to sketch it, so just 4 steps. The first step of sketching that parabola is to mark the y-intercept, which is the point 0, C. The second thing you want to do is you want to compute the axis of symmetry. That axis of symmetry is the line x is equal to negative b divided by 2a. And then once you've computed the axis of symmetry, you want to evaluate the value of y along that axis of symmetry. So put in x equal to this number you just computed in step 2, and then evaluate y. That will give you a point that is where the vertex is. And then finally, take a look at A. And if A is positive, then the parabola is going to go like this. It's going to be concave up. And if A is negative, then it's going to be concave down. So if A is greater than 0, then your parabola looks like this. And if A is negative, then it's going to look like this. And of course, if A is equal to 0, then you don't have a parabola at all, you have a line. Because then it's just bx plus c, which is a line. Okay, so that's just a quick refresher of what we did in class last. And now what we want to do is think about what are the different possibilities for x-intercepts. Notice I didn't mention anywhere here what the x-intercepts are. I just said that the y-intercepts are. You kind of run into them eventually. And when you do your sketch, you'll have some idea of where they are and how many there are and all that sort of thing. But let's sort of outline the possibilities. So the 3 possibilities. And let me graphically show you them. There are 3 possibilities. I'll graphically show you them, and then I'll give you a formula to see them as well. So this is the situation where there are no x-intercepts. This is the situation where there is 1 x-intercept. And this is the situation where there are 2 x-intercepts. And just for simplicity, I'm going to draw all the cases where A is greater than 0, so everything is concave up. So we're going to assume, okay, and what I'll do is I'll also write out in factored form the typical equations that you get. Okay, so let's go ahead and take a look at what they might be. So when there's no x-intercepts, this is the x-axis, this is the y-axis. So what does that mean? That means that the parabola cannot touch the x-intercept. It has to be concave up all the time. So it's concave up and it cannot touch the x-axis. So it's got to be something like this. Okay. And that's basically it. The curve never touches the x-axis. Now, if there's one x-intercept, it means that it touches the curve, or the curve touches the x-axis exactly once. It can't touch again. Well, if it goes down too far, it's going to touch twice. That'll be this case. If it's too high, it'll never touch. So one x-intercept is where it just touches down exactly one time. Right there. And then if you slide it down a little bit more, you get the last case where there are two x-intercepts. Now what I'm going to do now is give you the factored form of each, and we'll go sort of backwards. Let's say this x-intercept is capital A, and this x-intercept is capital B. So if you factor this polynomial, factor this quadratic, it has to have two, well, x equals 0 situations. So y has to equal to 0 in two ways. And one very easy way to make this happen is do this sort of thing. And there's potentially something out front. This is a constant in front. So what can happen here is if x is equal to a, if you put in x equals a, you get a minus a here. That's 0. 0 times anything is 0, so it forces you to be at the x-axis. Similarly, if you put in x equals b here, you'll get b minus b is 0. 0 times something is 0. So that's why this looks like the factored form there. Over here, well, it's basically the same thing except that a is equal to b. Well, what is that going to give you? That's going to give you x minus a times x minus a again. So that'll be x minus a squared. And what about over here? Well, here, I can't even get started. I can't even write down the a here because it just isn't there. So this is not possible. Okay, so we've got these factored forms, and it tells you about the x-intercepts, the different kinds of factored forms you can get. So then in the next video, what we'll do is we'll talk about converting between the factored form and between the standard form like this.